Hi everyone, I am Ananthalakshmi. I am the IIT Madras ETDCS expert faculty. Today I'll be discussing questions from 2020 JEE Advanced paper from the area of my expertise. Okay, so let's move on. So this is the first question of the paper 1 of JEE Advanced 2020. Okay, so let's go to the question. If the distribution of molecular speeds of a gas is as per shown in the figure, then the ratio of the most probable, the average, and the root mean square speeds respectively is. Okay, great. So basically in this question, they're asking you the ratio between most probable, the average, and the root mean square speed. So basically you need to know what you mean by most probable, average, and root mean square speed. This thing we are actually studying in gaseous state. Okay, and in gaseous state we already had a established graph, but this is not the typical usual case. They're giving you a new graph. Let's say this is the graph, and let's say this is how the molecules, the distribution of speed is, not the conventional way. So basically there is this is such a straightforward question. You just need to know the definitions of it. That's the whole point of JEE Advanced. You need to be clear with the theory. Okay, so first of all, let's find out what is the most probable speed. So as the name suggests, most probable speed means speed acquired by the most number of molecules or the greater fraction of molecules. So we can see in this figure, the y-axis is fraction of molecules and the x-axis is speed, right? Okay. So what is the most probable speed? We can see that the peak is this. Okay, the peak is this, and the corresponding speed, that means this will be our most probable speed. So basically we can see that is exactly the midpoint, right? Yeah, that will be the speed. Okay, so now we have plotted the most probable speed, BMP. Okay, now what will be the average speed? So we know what is average speed, right? Usually it's V1 plus V2 plus up till Vn. Let's say there are n molecules. In that case, when you take the mean of all the speeds, you will get the average speed. So here, since the graph is symmetric, when you average all the speeds, obviously, this is just maths. You'll again get the midpoint, right? That's common sense. You'll get midpoint. So we can definitely say V average is exactly same as V most probable. That part is clear. So if we know this much, we can definitely rule out the option C and D, right? Because now we know the first one should be 1:1. That is for sure. Now we have to talk about VRMS part. Okay. So VRMS is what? Root mean square speed. So root mean square is nothing but take the mean of the square of the speed, and then you have to take it a root like this. Wait, I'll write root of sum of the squares of speed. V1 square, V2 square, let's say up to, sorry, that was supposed to be dots, up to plus Vn square. And then average it. Total number is N molecules. Okay, so if you take, in that case, we can't really say the mean is midpoint, right? Why? Because, by math, we know higher speed, okay? Higher speed, when we square and then we add, then for squares, the more contribution will come from higher numbers. So when you take the average, you won't get exactly midpoint. It's not like every molecule will have equal contribution, but the square function is exponential. So, and hence the more higher, the more the average will be more closer to the higher number. So definitely we can say VRMS will be definitely greater than V average. we don't even need to calculate how much because it's crystal clear. So it'll never be equal. And again, A means everything will be equal. So that option is also ruled out. So correct answer is B, where VRMS will be greater than V average. But we have already found out that V average is VMP. Okay. I think this question is covered. Now let's move on to the next question. Okay. Oops. Okay. Sorry. Yeah. This question is from organic chemistry, basically serial chemistry. Okay. So as we can see, we just have to find which one of the following options represents identical molecules. So now what we are seeing is Newman projections of 4 molecules, out of which some are identical. We have to find the identical molecules. This is basically a cakewalk question because all we need to know is how to convert this Newman projection into the normal structural formula. Okay, so we'll find it out one by one. Okay, so first let's break down P. Okay, so as we can see, this is the front carbon and the whole circle is the back carbon. Okay, I mean, the first one, I'll explain it a little bit in detail. The rest of the thing, it's just the same way. So in the first one, we can see the groups. So first we'll write the front carbon and back carbon like this. And what are the group attached to the front carbon? We can see CH3, CH3, C2H5, right? So we'll write it CH3. Oh God. Okay. CH3 and C2H5. Now, what are the groups attached to the back carbon that we can see OH, CH3 and CH3. So writing it OH, CH3 and CH3. Great. Now, let's write for Q. Okay, similarly, when we write all this, we'll finally find out. Okay, so for this, the front carbon, one group is H, as you can see, and another group is C2H5. And then we have this group, CH3 twice, okay, CCH3, yeah, C, CH3, CH3, OH. Okay, and now coming to the back carbon, H, H, and CH3. Great. Oh, this is shabby, very shabby. Okay, maybe I'll try to write it neatly. Okay, so again writing C, front carbon, you have H, you have, okay, C2H5, I'm writing as ethylene group. Okay, maybe C2H5 only I'll write. This OH, sorry, C, OH, CH3. I hope you're following what I'm writing. I'm writing this group here. Okay, that is this. And then for back carbon, what are the 3 groups? Yeah, it is easy, which is H, H, and CH3. Okay, right. Now about coming to R. Okay, so we'll again write 2 carbons, CC. So I hope the methodology is familiar to you. We have to first list out the front carbon, back carbon, and accordingly write the attached substituents. Okay, so I'll write fast. CC, CH3, OH, and CH3. Okay, the groups attached to this carbon will be H, C2H5, and C2H5. Okay, great. Now, coming to the last one, S. Again, we'll write 2 carbons and then we'll write it branches. Okay, so H, H, CH3, that's shabby, I know, I'm sorry. OH, C2H5, and one more. CH, okay, this is basically isopropyl group, CH3 twice. This is basically organic chemistry and stereochemistry together. Okay, this is a little bit shabby, I know, but then when you write it neatly in the notebook, it will be, you'll be able to identify it properly. So, okay, so there is okay, so now we have to find the identical molecules, right? Yeah. So as we can see in the first, for first carbon, it's CH. There are 2 CH3 group and 1 ethyl group, C2H5 group. Okay, first we'll see, can we find any carbon in anywhere else which have this configuration, relative configuration, which has 2 CH3 and 1 C2H5 attached to it. So I'm checking here whether Q it is there. No, in Q we can't find anything like that. In R, can we find anything of that sort? No. Can we find anything in S? No. We can't find a carbon where you have CH3, 2 CH3 and C2H5 attached. So there is nothing similar to P here. Yeah, that's pretty sure. Now coming to Q. Let's see. Yeah, in Q there is a little twist. Now if you take this as a group, then oh wow, great. If you concentrate on this carbon, then the substituents attached to this carbon will be C2H5. This is C2H5, right? This whole thing is C2H5. Yeah, that is a little tricky part here. You have to find through the diagram. Okay, so the group attached to this carbon will be C2H5, C2H5, and H. Now, can you see any this kind of a arrangement in somewhere else? Yes, we definitely can see C2H5, C2H5, H. Here also, right? C2H5, C2H5, H, and C2H5, C2H5, H. Now, this thing, what is the configuration around this carbon? OH, CH3, CH3, and OH, CH3, CH3. So basically, we found out what is the right configuration. The identical molecules. It's definitely Q and R. And this is basically a single correct question. So we found it up. We found the answer already. So yeah, I think we can go to the next question. Yes. Okay, this is again a question from organic chemistry. Basically, if you know how to name an organic compound, basically if you know the nomenclature, then you're good to go with this question. So very first step of finding is you have to find the parent chain. You have to number the chain and find whether when you number it matches the given compound name. Okay, so the name is, as we can see, 3-ethynine, 2-hydroxy, 4-methyl, hex 3 ene 5-inoic acid. So this is basically, this last part actually gives what is our parent carbon, like how many carbons are there in the main chain, I mean the parent chain. So hex indicates that there are 6 carbons in our main chain, and there is a COH group in our main chain. So obviously carboxylic acid are higher, priority. Okay, so we should start from numbering. We should start numbering from the carboxylic acid. So we'll actually learn about the priority orders in organic chemistry when you come to that. So firstly, we now understood that there are 6 carbon in main chain, and it starts with carboxylic acid. So now we have to number each compound and see whether it matches the positions given. Okay, so let's start numbering. This is 1, this is 2, sorry. Oh god, my stylus pen is really bad. I'm sorry for that. 1, 2, this is 3, this is 4, this is 5, and this is 6. Now if you see, my 3 is really bad, but just bear with me and understand that this is 3. Okay. Okay, it's 3. Fine. So yes, now we can see hydroxy is at 2, so that is correct. But yeah, even 3 ene is also correct. But yeah, 5-inoic acid is also correct. But what is not correct is 4-methyl. We don't have any methyl group at 4. So this is wrong. We eliminated that option. Now, next option, we can number B. Where will we start from this acid? 1, 2, 3, sorry, 4, 5, 6. Okay. Okay, and also when we determine the parent chain, we have to make sure that all the priority functional groups are included in the main chain. Here, we should make sure that at least one wine, okay? I mean, not wine, ine, the triple bond is included. Yeah. So 1, 2, 3, 4, 5, 6, I think numbering is done. Now, as you can see, there is hydroxy at 2, perfect. 3 ethynyl, sorry. Yeah, 3 ene is there, correct. Now, 5 inoic, ine is there at 5. Do we have 4 at methyl? No. We have ethyl at 4, so this is also wrong, not methyl. Now C, now number it again. 1, 2, 3, 4, 5, 6. Again, we have 2 at hydroxy. We have 3 ene, 5 ine, but again, this methyl is the problem. We have to have a methyl at 4, but we have something else. So this is also wrong. Okay, now basically it boils down to only one option, which is D. But then let's make sure of this case too. So 1, 2, 3, 4, 5, 6. Okay, 3 is bad. And you understood that. So here, if we check, at 2 we have hydroxy, perfect. Now at 3, correct, exactly at 3 we have ethynyl, and we have at 4 methyl. Yes, everything works, so this is the right answer. Okay, so after doing 3 options, we'll be sure that D is the answer, but then just for the sake of understanding, I explained, okay, the B part.